Hi everyone, in today's video you're going to learn about Docker and containers. My name is Alexander and this channel is all about showing you how to become a highly paid IT professional fast. So let's get started. This video is split into three sections. In part 1 you will learn the theory behind the Docker, in part 2 you will learn how to use Docker by means of command line, and in part 3 I will cover Docker Compose. So part 1 will consist of the following topics: what is Docker, containers and virtual machines, what are containers made of, containers are ephemeral, why you should use volumes, how Docker containers and images are built, what is Docker Compose, and what is Docker repository. So what is a Docker? Docker is a containerization technology which is very popular in DevOps. It is alternative to virtual machines, not a substitution. It's a very important but subtle difference which we'll cover later. A scale of Docker can range from a single container to billions. Now, whenever you're running a scale of Docker containers, orchestration is still required, which is not covered in this video as it is aimed for beginners. Let's compare containers to virtual machines. First of all, what is a container? A container is a standard unit of software that packages up code and all of its dependencies so the applications run quickly and reliably from one computing environment to another. And this small diagram shows you visual comparison between virtual machines and containers. As you can see, Docker Engine is what hypervisor is to virtual machines. The Docker Engine implementation will of course vary from operating system to operating system, though in most cases Docker can be used across different operating systems without much differences. So in this brief table we are going into more details comparing Docker to virtual machines. First of all, I would say that comparing directly Docker to virtual machines would not be a very accurate comparison, because Docker does not replace virtual machines. For instance, if you want to run, let's say, Active Directory or do hardware abstraction, Docker would not be appropriate. So depending on your needs, either containerization or virtualization may be more appropriate. So let's look at these differences. So when you are using Docker, you are abstracting at the app layer, but when you are using virtual machines, you are abstracting at the physical hardware level. When you are running Docker, OS kernel is shared among the containers, but in case of virtual machines, each guest OS runs its own kernel. Docker container is not a complete operating system, while guest OS, when you are virtualizing, is a complete OS which can be converted into a standalone OS and installed on a dedicated hardware. Finally, when you are running Docker, you have a small overhead, but when you are running virtual machines, you have a big overhead. So now let's look at what the containers are made of. To start with, Docker containers are created from Docker images, which in turn are made of these, as you can see, layers identified by cryptographic hashes. Each layer is represented by a standalone command from a Dockerfile, which we will cover in this video. It is important to bear in mind that image layers are read-only, while container layers can read and write. We are not going to go into in-depth explanation of what containers are made of, as this is aimed for beginners, and the concept of Docker images, their insights can be very complicated. Containers are ephemeral, and why you should use volumes. Containers are not meant to retain state, and by their nature they are stateless. So once a container is gone, everything that was inside the container will be gone permanently. So if you want to store persistent information or state, you need to use volumes. Let's say you have a database such as MySQL. There are different ways to store information in Docker. These three types presented are bind mount, volume, and temporary file system mount. So we will look into a more in-depth difference at the next slide. So let's start with volume. Volumes are stored within the Docker's file system on a host, and they should be accessed directly only by the Docker, otherwise you run the risk of breaking the volume. A good use for volumes are databases such as MySQL. You should bear in mind that it is also possible to use remote systems or even cloud storage providers which can be connected by means of volume drivers. Now, volumes can be either anonymous or named, and the recommended choice is of course to go with the named volumes. The next one are bind mounts. Bind mounts allow you to mount any information on the host system and allows easy human access both from the host side and from within container. A good usage would make log files and config files. Bear in mind that using bind mount can expose sensitive data from the host. Another thing to bear in mind is that bind mounts are known to be slow on macOS and Windows with W2SL. The next one is temporary file system, which allows you to store information in the host system memory. A good example of that would make non-persistent information or sensitive information. Now this can only be used on Linux host. And the final choice, the final type of volume, named pipes, allows communication between hosts and containers, which can connect to the Docker Engine API. A popular choice for using named pipes is for running third-party tools. Now bear in mind that it can only be used on Windows host only. As an overall summary, the best or recommended go-to choice are named volumes. It's even recommended in the Docker manual itself. Now let's look at how Docker containers and Docker images are built. It starts with a Dockerfile, which is a text-based file where a single command is represented on each new line. This Dockerfile is used to create or build Docker images, which, as you remember, are read-only images. These Docker images in turn are used to create or run Docker containers where you're permitted to do read and write operations. So now let's cover Docker Compose. Docker Compose is similar to container building process. However, Docker Compose allows you to configure service containers for application container and run them together from a single config. So a good example would be a LAMP stack. Let's say you have your web application and container which runs your application would be known as application container. Now Apache, MySQL and PHP would be called service dependencies or service containers. A good rule of thumb is to run each service in its own container. Running all of your dependencies in a single container is considered anti-pattern. Remember the slide where I covered or compared virtual machines to containers. Remember that containers are not virtual machines, so do not try to run everything in a single image. Now let's take a look at the last topic of the part 1, which is Docker repository. Building custom images can take a significant amount of time, especially if you have a very big image. So in order to speed up the process, such as in case of continuous integration, we are sending our built images to what is known as a Docker repository, which can be used for publicly available images, including private ones. So the idea behind Docker repository is that you build an image once, you upload it to the repository, and then you can use it everywhere without having to build it. It is a bit like a guest operating system, which you download from the internet, and it comes pre-configured. So all you need to do is download it once, boot it up, and you can use it immediately. A very popular choice for public images is Docker Hub. It is free of charge for public images. All you need to do is just sign up. So now let's move on to the part 2, which is more hands-on part of this video, where I will be showing you how to install Docker, how to start your first container, how to expose ports, attach volumes, access a running container, detach from a container, and finally how to do some simple housekeeping such as removing container, volume or images. Finally, I will show you how to create your own custom image using Dockerfile, and I will also go through the best practices so you don't do what is known as beginner's mistakes. Alright, so now let's talk about installing Docker and doing some practice exercise. Before I get started, I wanted to give you a word of caution. You might come across an old technology known as Docker Toolbox. Now, Docker Toolbox used to be quite popular in the past, but now it has become outdated and is no longer in active development. So we are going to be using Docker Desktop instead, or Docker Engine if you are on Linux. There are some differences in the implementations of the Docker across operating systems. I will cover them briefly now, and then I will show you the installation process. So when you're installing Docker, you have for either Mac or Windows, you can install what is known as Docker Desktop. This is a purely convenience feature that adds some nice GUI interface on top of existing Docker commands. In case you're using Linux, you don't have Docker Desktop available, but for the most part it doesn't matter because we are going to be covering command line usage in this tutorial. And most importantly, since this tutorial is aimed at DevOps, you need to become really good at command line experience with Docker, as DevOps servers, as you know, are primarily Linux and more often than not they are headless, so you won't really have a GUI interface. So now let's get started installing it. To install Docker on Mac or Docker Desktop on Mac, you have to go to docker.com website and hit Get Started. Let the website load, and in the first column you see Docker Desktop available for Mac, and you would hit Download button where you would download a DMG file. You would open it. This file is a little heavy, it's about 500 megs in size, so it may take a little longer than your average application to get started. So give it maybe 1 or 2 minutes for it to verify the DMG image. Now we have finished verifying our DMG image, so you would just install the Docker Desktop for Mac as your any other application. You would just drag and drop it into Applications folder. Apologies. And now it's starting to copy the application. As this application is about 500 megs in size, it will take a few minutes or maybe up to 10-15 minutes depending on the specs of your computer, so give it some time. So now that we have finished copying our application, go ahead and open it. You can use Spotlight, you can navigate to the application folder and just double click it. Doesn't really make any difference. And then you would open it. Let's see. When you are opening it for the first time, it will verify that the signature of application matches what is being installed, so you don't accidentally install, let's say, malware. And depending on the specs of your Mac, this can take a few seconds or it can happen instantaneously. And we would say open. And let's see, now it should open up. You would say it needs privileged access. You would say OK. You would provide your password to install helper. Let me double check that again. And now, as you can see, Docker Desktop for Mac is starting. So what you can do after you have installed it, you can close now the DMG file. It is no longer needed. And now the dashboard will open in a moment. You can also check the status. The dashboard is open. And this is how you would check the status of the Docker dashboard. Just click on this icon. It will show you a list of available menus. And for configuring it, you would hit Settings, the cog icon. This is not available yet as Docker is starting. Everything here is pretty much straightforward. No specialist technical knowledge is required. And in case you have any issues, you would navigate to the bug side, where you would have different simple troubleshooting steps, including the uninstall option. And this pretty much covers installation of Docker for Mac. Now, the last part I wanted to show you, which is something you might want to configure if you are using Docker on Mac, is you go into Settings, you go into Resources, and you might want to adjust the settings according to your system specifications. So depending on how much, I say, RAM, disk space and CPU, you might want to adjust these toggles so that they match your system specs, so you don't end up either using too much resources for the Docker or using too little. And the other thing is file sharing. It's actually using bind mount, and as I have mentioned, it is possible to accidentally leak or expose sensitive information to the container when you bind mount, so you might want to review this information. Now, with this in mind, let's move on to the next operating system. So now I will demonstrate how to install Docker Desktop on Windows. Let me open up the remote desktop, and we are using for this particular demonstration Windows 10 Enterprise Evaluation. So you would follow the same principle. You would go to docker.com website, you would hit Get Started, and then you would download the file. I have already downloaded the file to speed up the process, so you would install it just like any other application. Double click or right click open. Grant the admin rights, and now it will begin the process. Just like with Docker Mac, this file is about half a gig in size, so it will take a bit of time to download it, so allow it to maybe up to, let's say, half an hour depending on your system. For simplicity's sake, you can leave this on, these two checkboxes, and you would hit OK. So this process might take somewhere between 5 to, let's say, 15 minutes, depending on the specs of your system. So once the installation process has finished, you would close the installer, and on a desktop you would find the Docker icon. So the process here would be similar to Mac's one. You would just double click on an icon and go through the same steps. And instead of having the the Docker for desktop icon at the top, you will have it here at the bottom, just like all Windows applications. And that's about it for Windows installation. Now, so last but not least, I will talk about installation of Docker engine on Linux. In particular, we will use Ubuntu image. So Docker is supported on all major Linux distributions, including CentOS, Debian, Fedora, Ubuntu. And this is, as you can see, the official website, so they provide pretty easy and straightforward instructions. As I have mentioned in the beginning, Docker for Linux does not offer Docker Desktop, so everything on Linux will be using command line. So let's get started. First of all, let's run update to make sure that our dependencies, the list of our dependencies is up to date, and let's also immediately upgrade them. Now, depending on the specs of your machine, this process can take a while or it can be quite quick, and in the meantime, let's become more familiar with the process. So the recommended process is to actually set up the repository for the Docker engine and install it from there. There is also an alternative way by means of installing Docker engine from a package, but the recommended way is to use the repository. And as you can see, these commands are pretty straightforward if you are familiar with Linux, and they're very easy to follow. So let's see, our update process is halfway complete. Let's wait for it to finish, and in the meantime, let's prepare our first command. So we have already run apt update. By the way, apt-get or apt in this particular case doesn't really make a big difference, but when you use apt instead of apt-get, you get a better visual interface, such as this progress bar, which you wouldn't get if you would have used apt-get. And let's specify here yes. All right, so let's copy the first command. By the way, these commands have been already prepared for you, so you need to retype them. You just simply copy and paste them into your terminal. This is almost done, so let's wait a few more seconds for it to finish. Alright, so we have finished updating our dependencies, and let's run the first command. Hit enter, hit yes. Alright, that was fast. Now let's install the official GPG key. You just copy and paste it. Hit enter. Alright, so the next step is actually requires a visual verification. We need to verify that the key we have installed has the following fingerprint ID. So let's copy the key. And as you can see, it matches. By the way, as you can see in this page, we are using sudo. And generally, you would use sudo as it is generally not a good idea to run as a root on a regular basis. However, this particular Linux Ubuntu box is purely for demonstration purposes, and hence it is running root user. So in other words, normally you would not want to run as a root, but for demonstration purposes it is completely fine. Once we have verified our fingerprint, let's add the new repository. My apologies. And add the new repository. And now let's run one more update. Update to make sure that we are pulling the latest changes from the newly added repository. And now let's install our Docker engine. Right? And we would want to add one more command, which is Docker compose. Now, Docker compose, we are going to use it in the third part of this video tutorial. And I have forgotten to add apt, right? And hit enter. Now this process can take a bit of time, since it installs about half a gig worth of binaries and other material. So this can take a few minutes, or maybe even up to, let's say, half an hour, depending on how fast or slow your system is. So it's going relatively fast now. And now let's see, the command has finished and we are pretty much done at this point. Now let's verify our installation. We would type which Docker it is installed, which Docker compose it is also installed. If you run Docker, it works. Docker compose. Alright, it works. So this pretty much wraps up our installation part of this video, and in the next part I'm going to show you how to run your first container. So before getting started, there is one important website you need to keep in mind or keep handy while you're learning the Docker. This is a command line reference available on Docker Docs website. At the moment I have opened Docker Run, which is the command we are using to get to know Docker, and as you can see there is quite a bit of parameters available for it. It's a good idea to become more familiar with it as you are learning, and as you become more convenient, it's a good idea to quickly skim through the other available commands so that you are familiar with them. It is not really necessary to go into depth of each command and learn it by heart, but it's a good idea to be familiar with these commands in general, so if you encounter them, you have at least rough idea what they do. And as the need arises, you can always look up in this reference the specifics or specific parameters of these commands. So let's get started. To run your first container, you would type docker run it. By the way, I will show you the command now, run it, and then I will explain it to you using this reference so you become familiar how to use the reference website as well. We'll type docker run it hello-world. Hit enter. As you can see, the image was not found. Let me scroll back up. The image was not found. It says unable to find the image, and it starts pulling it. And as you can see, it is downloading it in layers. As you remember, the Docker image is made of layers and it is read-only. And one cool thing about Docker is that unlike virtual machines where you have to download the entire image of the guest operating system, when you are downloading an image, each layer is downloaded separately. So let's say you have two images which, let's say, share about 80% of layers and they only differ in the remaining 20%. So when you're going to be downloading the second image, you would only download the difference of that 20% instead of downloading the entire image, which makes Docker very efficient. And as you can see, hello from the Docker, it shows that your installation appears to be working correctly. So this is a very simple image just to show you how things work. Now let's look up on the reference, the IT command. So the IT command, what it does, it assigns a name and allocates a pseudo TTY. So in other words, if you want to be able to access the container and immediately default to shell, you would use the -it parameter. So now let's move on to the exposing ports part. So now I will demonstrate how to expose ports for your container. The process is very simple and there is a dedicated parameter for that. It's -p or $expose, and in the reference you can find it under publish or expose ports. So what I would say from personal experience is that expose command or the shorthand syntax is not very popular because it doesn't allow you fine-grained control over this command. So my recommendation is to always stick with -p. And the way this command works is the following way. Personally, I prefer reading it from right to left as it makes more sense for me. So first of all, you would specify the protocol, which is optional. It's not a necessity to specify it. And you have a TCP, UDP, and SCTP, followed by the port used by the container, followed by the port exposed to the host, followed by optional IP to which you would like to bind the port. So to clarify, what is the purpose of specifying IP? If you would like the exposed port to be available outside of the host system, you would omit this IP. However, if you like to restrict the published port only to the host system, say for security reasons, you would include it, and this line in the reference explains the same thing. So now I will go ahead and demonstrate to you how to publish the port. Before starting this, I will mention that for this example, I will use a different image, which is Nginx Demos Hello. As for this example, we need an application which actually uses ports. And as you can see, this is Docker Hub. And as I have mentioned in part 1, is very popular Docker repository, especially for public images. And the last mention is that you may also come across the command with P capital, which is called publish all exposed ports to random ports. This command exists, however, I would not necessarily advise you to use it due to this part. You see, when you are exposing the ports explicitly, i.e. you specify container port and the host port, you always know where the port will end up. However, when you use this command, it can become more confusing in a sense that you won't be able to tell which port you have exposed. So in other words, you would need to look in the Docker file to be able to deduct that. So let's go ahead and expose our ports. Let's run Docker, run P. We would specify the host port, and I would specify the container port, and then I would specify the name of the container. Copy and paste and hit enter. So we're gonna download our image now, and it's gonna download it layer by layer. As I have explained, it's very efficient when your images are using a lot of common layers. And depending on the size of the layers, it can be very fast, very efficient. So let's go ahead and try. We're gonna specify our local port, local IP, hit enter, and there we go. And if you look at our terminal, we can see that we have successfully reached the container. Now I'm gonna specify a different, by the way, it's Control-C to terminate the running container. I'm gonna specify a different port this time. Let's call it 8888 and hit enter. Alright, it's running. So now let's update our URL, 8888, hit enter. And this has also worked. So as you can see, the container has this IP on which it is listening on port 80. If I'm not mistaken, Nginx by default uses port 80. So now I will demonstrate to you how we can use the IP to expose or limit our container to the outside world. And for this example, I've used a remote Docker engine to demonstrate in practice how it works. So now I will demonstrate the commands, but before doing this, I will mention that for this example, I'm using Nginx demos container image, as we need an application that will have a daemon that will listen to a specific port and will show some valuable, let's say, useful output that we would be able to confirm that everything is working as expected, and a simple Nginx is a great way to do that. By the way, this is Docker Hub, and as I have mentioned in part 1, it's a really great place for exploring Docker ecosystem. Finally, I would mention that there is one more command which is specific to Docker Run, and it's called publish all exposed ports to a random port, which is spelled -P. Now, the reason why this command, I would say maybe not so popular, is because the ports are being published to a random value. It's not deterministic, so maybe it's a great way to, let's say, troubleshoot something or just experiment with the system. But if you're developing a container where you expect everything to work the same, no matter how many times you started or no matter what host OS you use, it's not so great way because of this randomness. So let's go ahead and expose our ports. Now, to be able to demonstrate how binding to the local IP works or does not work, I'm going to use a remote Docker system instead of a local one. So let's go ahead, Docker run p. Let's expose our port and let's copy the image name, right? And hit enter. Alright, so the system is listening now. Let's go ahead and test it. Now, because this is a remote system, I'm going to use a remote IP. Let me quickly grab it, type it here, and let's see. There we go. So this is our public IP, and this is IP of the container, which is listening on port 80. So let's change our port, let's say, to 8080. And as you can see here, we can confirm that we did, in fact, receive a request on Nginx. So let's stop running this and change the public IP. Let's say change the expose port to 8080. Hit enter. And let's type here 8080. And it also worked. And let's confirm it. Yes, we did in fact receive a request on port 8080. Now, for the sake of demonstration, let me show you that we will change the container's port to 8080. So, as a reminder, the port on the right is a port used by the container, and the port on the left is the port which is exposed to the Docker host. So let's try it, port 8080. And as you can see, nothing is happening. This is because the container, within the container we have a daemon running Nginx, and this daemon is actually listening on port 80, which is why nothing is happening. Now let's go ahead and test what will happen if I would specify the IP. As I have mentioned, we are binding the exposed port to a specific IP. Let's hit enter and let's stop and let's try again. As you can see, nothing is happening because the system, the Docker host, has bound this port to this specific IP. In other words, your system needs to be on this IP to be able to access this port. And for demonstration purposes, I have SSH into the system, and let me run here request locally. As you can see, it has worked. We have received requests on Nginx. And now let's try also this IP, and it has worked. Now I will demonstrate to you that if you try to use a different port, it would not work, right? Because as you remember, we have exposed here port 80, not anything else. So to be able to use a different different port, I would need to change my command. And we hit enter, and now it works, but port 80 does not work. So this pretty much in a nutshell should give you a good understanding of how to expose ports by means of Docker run command. So now I will talk about volumes. How to create volume, how to attach it, and I will talk about two types of volumes, bind mounts and regular Docker volumes. So first of all, I will start talking about regular volumes, since as I have mentioned in part 1, this is the recommended approach now, since it has evolved a lot more as compared to bind mounts, and is a preferable way to store persistently data in containers now. So first of all, let's look at the command, which is just right above publish or expose ports, and it's called add bind mounts or volumes using the -- mount flag. Now, right above it, you might get confused by it, so I will mention it. There is mount volume or -v command. Now, we are going to use mount volume for the following reason. Unfortunately, Docker's documentation is quite big, so sometimes some of the things are not as consistent as you want it to be. So, in particular, new users should use mount syntax. Unfortunately, this is not mentioned if you open volumes page, but it's only mentioned when you open the bind mounts. But I will mention it so you're more aware. So mount -- mount is a preferable syntax, even though -- volume or -- is still supported. You are encouraged to use -- mount. So first of all, before attaching a volume to a container, you need to create it, and there is a dedicated command. Actually, there is a number of commands specifically for volumes. If you open Docker CLI reference, you can find Docker volume with several subcommands available, which are pretty self-explanatory. You have your volume create, which create volumes. We have your volume inspect, which would display information, detailed information. You can list volumes, and you can essentially prune and remove volumes. So the difference is that prune will remove only unused volumes, whereas remove will simply remove a volume. Now, a word of caution about removing data in Docker is that these actions are not reversible unless you will do a manual backup. So it is not like on Mac where you delete file and it goes to trash, or in the Windows. This is very similar to how Linux works when you run rm command from command line. once you RM something, you cannot remove it because it's not in the trash, so you need to revert to your backup in order to restore data. So let's go ahead and create our volume. And by the way, as I have mentioned, there is an optional parameter here, driver, in case your volume, let's say, is using a remote system or a cloud provider. Now, in this particular case, I will keep it simple and we will use just a local system. So I will go ahead and create the volume, docker volume, create my data. And we have created our volume, very simple. So let's inspect it, docker volume, inspect my data. And this is how the inspect command works. It shows pretty straightforward. By the way, mount point is listed as an actual data path on the system, and if you would look at this data, you'll see that it is a folder that exists. But as I have mentioned in part 1, when you are using volumes, you are not meant to be modifying the data manually. In other words, you're not meant to do, let's say, cd into the mount path and manually add data. You're meant to do it either from container or let the Docker handle it for you. And the reason for that is you may accidentally break your volume, and then it would be very difficult to repair it or fix it. So volumes are not meant to be user accessible directly. Instead, you are meant to access a running container, and from within container access the volume. If you would like to mount data, let's say existing data, config file log, bound mount is the appropriate way to do that. And finally, I will show you a few commands. Docker volume ls would allow you to list your volumes, and as I have mentioned, it is a local, it is volume which is using local file system. And just for the sake of showing you how it works, I will show you how to remove volume, docker rm my data. Oh, my bad, docker volume rm my data. And that's it. So as you can see, you have to be very careful with removal, as this command would simply just remove the volume without asking you, let's say, confirmation questions, etc. So let's create the volume again and show you how to attach it to the running container. So now I will recreate the volume, docker volume create my data, and I will show you how to attach it. So I will show you the command and I will explain to you how it works and what it does. So it's pretty straightforward. We have our docker run -it, which means it's going to be interactive session with a container. I'm using Docker, and then I'm providing here bash. Now, what does this mean? Let's see. Let's go to the docker run. And essentially, the last one is the command which we are supplying to our container. So we have specified the name, it's of the image, it is Ubuntu, and then we are specifying the command here. So what this means is that we are specifying that we want it to be an interactive session, and once the container is ready, we want it to go into a bash shell. So the next part, -- mount, is what we are using to mount our volume. So when you are using, let's see volumes. So when you're creating a volume, you have actually quite a few of choices here. So first of all, you need to specify the type, as I have done it here, type volume. After volume, I will cover bind mount, so for the time being, let's focus on the volume. First of all, you need to specify the source, which can be spelled either as source or as src. So I'm specific because I'm using a volume, I need to specify the name of my volume. And finally, you need to specify destination, which can also be spelled as destination, DST, or target. And I'm specifying that I want to mount my volume in the root as / my -data. You have additional options, read-only and volume options, which can be specified more than once if you would like to add some additional options. This is usually used if you are using a driver which requires additional options. Let's say you are using a cloud storage provider, and let's say you need to specify perhaps credentials as an example. So let's go ahead, hit enter to run the command. So it will quickly pull our Ubuntu image, and we have now entered container. So let's print my current working directory. We are in a root, and let's do cd my data. So as you can see, the data was successfully mounted, and let's create here some data. Touch my file. And to demonstrate that containers are ephemeral, let's go to the root. Let's make a new directory. Let's go to new directory and do the same thing, my file. So now let's exit the container, and let's repeat the process. Let's create a container and mount our volume. So let's see. Now let's go to my data, ls, and we have my file. So let's go back to the root. Let's go to cd new folder, new directory, and as you can see, it's not here. lsl, and let's examine manually. What do we have here? As you can see, our folder is gone. So this is what I have meant in part 1 when I have said that containers are ephemeral. So the data which I have created in the volume have persisted even though the initial container was gone. But the data which was created directly in the container is now permanently gone. So this is our container, but as you can see, the directory which I have created, new directory, is simply not here. So this is something to bear in mind, that if you have any data which needs to be persistent, it needs to be stored in a volume. So for example, database such as MySQL, any data files, let's say CSV file, any maybe exports, etc. So now I will move on to the bind mounts. Oops. So now I will demonstrate how to use bind mounts to mount a local directory. So I will show you first the command, and it's very similar to how you would mount a volume, but I will show you something interesting, how to mount your current working directory. So let's examine the command first. The only difference is actually compared to the previous command is a mount, so I will focus on it. So for type, I would specify bind, you would put comma. By the way, it's run no spaces, so the whole mount command is written without spaces, separated by commas. We start with our source, which is $, parentheses, pwd, which is essentially subshell, which would be expanded into, let me show you, this value. So instead of manually hard coding the value, it allows you to save time and also make it more dynamic. Destination, we are using the same path and we are accessing Ubuntu Interactive. So let's go ahead and try it. Hit enter. Now let's see. We know that on the remote Docker engine we have the following folder: root host - folder. So let's try to access this command, this path, host folder. There we go. Let's now do ls, it's empty. So let's create a new file, and there you go. And remember, as I have mentioned, be careful when you're mounting root level directories, because if you have subdirectory which has, let's say, secret files, passwords, authentications, credentials, etc., they would be accessible from the container. So for example, let's say I would do the following: touch my secret, and I would add some text to it, and I would show you I'm now within, I'm running a container in the interactive session, and as you can see, I can access the file. But the same way, let's say if you're using a log file or etc., if you're gonna create a new file from the container, it would be created in the host system as well. Touch new file ls. So as you can see, bind mount is pretty much mounting a physical directory directly to the container. And as you can see, the process is pretty straightforward and very easy. So in summary, if you are going to store any data, generally volume is a preferred approach. However, if you need some kind of files which you would like to be able to edit manually, such as configs, log files, bind mount is the better approach for that, but remember to avoid accidentally exposing any sensitive information. So this pretty much should wrap this up for the volumes, and the remaining part is I will show you how to access running container, how to detach a container, how to do housekeeping, and finally, the final part of this topic, I will show you how to create your own custom image using Dockerfile. Now I will demonstrate how to run containers in daemon or background mode and how to attach to them subsequently. For this example, I will use this image. And let's get started. So far we did docker run. Let's specify the port so we can use it afterwards, and the image name, and hit enter. So as you can see, the container started immediately, but it has occupied our terminal, so we are not able to run any more commands. So the workaround for that would be either to start a new terminal, or terminating execution of the current container via Ctrl+C, executing any other commands we want to try, and then running a container again. But as you can see, it can be quite inconvenient. So what we can do is we can supply a special switch called -d, which allows us to run container in the background. So we would type --detach and run container in the background. So let's try this. And you can see we have received the container's ID, and all the standard input output was returned back to us. So now let's check if the container actually works. Let's do curl localhost. And as you can see, it actually runs fine. And there is another command where you can check the status of the containers. You type docker ps. And as you can see, it shows us that we have our current container running, and here we have a short container ID displayed. So to terminate the container, you would type docker stop and specify the container ID. Now, if you try to curl localhost, it says the connection refused because we are not running any service or daemon which is listening on that port. So now let's run the container again, and this time let's attach to it. So how this works? We started our container in the daemon or background mode. Let's copy its ID, and now let's run docker attach and specify the ID. Now we have attached to our container, and it is running now in the foreground mode. Now, when you would press Ctrl+C, this would actually terminate the container, and we can verify it via docker ps. You see, we don't have any container running. If you remember from before, when I would type docker run, I would specify the IT command, which stands for, let me show you, I stands for interactive, keep std in open, even if not attached, and T stands for allocate a pseudo TTY. Now, why is this important? when you're running Docker attach, you can actually detach from a container without killing it. So let me show you. To stop a container, we would run Ctrl+C, which would send kill command. But if the container was started with int, you can detach from container and leave it running by using Ctrl+P, Ctrl+Q. So let's try it. Docker run. And now I would specify also here IT. And we have our Docker ID here. So let's do Docker attach. Specify the container ID. And now let's press Ctrl+P, Ctrl+Q. And we have sent the escape sequence. And now let's check if the container is running. Docker PS. So as you can see, the container is still running. So this should pretty much cover the idea of how to start the container in daemon mode and how to attach to it, in other words, how to bring it back to the foreground. Now, before moving on to the next part, I would like to show you how you can assign unique names to containers instead of having to rely on long and confusing container ID strings. So to allocate a name, you would simply have to supply a parameter -- name followed by unique name. So let me demonstrate to you how it would work. Let's copy our image. And now let's do container run -it -daemon, specify port. And now let's specify name, let's call it nginx, and specify name of the image and hit enter. We are pulling an image and here we go. So if we would run docker ps, you would see that our container name, where is it? Names nginx. So let's say we want to attach to our container, we would say docker attach nginx. And let's detach, Ctrl+P, Ctrl+Q. And now let's say we want to stop the container, we would say docker stop nginx. And with this way, it becomes much easier to deal with containers. So instead of having to memorize long ID strings, you would simply remember a unique string. Now remember that the string has to be unique and you cannot use the same name for multiple containers. So let's say we start a container and we get an error. It says error response from daemon conflict container name already exists. In other words, it's in use. So what's important here is that when you have stopped the container, it's not removed. In the next part, I will show you how to remove containers. This is actually part of the how to do housekeeping, how to remove volumes. And I will show you some other nifty parameters that allow you to simplify and somewhat automate management of your Docker host. So what is housekeeping? When Docker performs any operation such as stopping a container, downloading a new image, or creating a volume, that information is not removed when you stop using it. It is actually kept for performance reasons. And over time, you can consume a lot of disk space with these unused images, containers, volumes, etc. So I will demonstrate to you some commands how to reclaim the disk space back. In the Docker documentation, there is a page called Prune Unused Docker Objects, which goes over popular commands to remove containers, images, etc. And now I will go over these commands in more depth. So let's start with prune images. By default, if you execute docker image prune, it would remove just dangling images. So what is a dangling image? It is an image that is not tagged and is not referenced by any container. So in other words, it is orphaned. Let's see. So By default, Docker image prune would remove only orphaned or dangling images. If you would like to remove all unused images, not just dangling ones, you would need to supply --all or -a command. And of course, there is a filter if you'd like to be more fine-grained instead of just removing all images. Finally, all of prune commands come with do not prompt for confirmation flag. My personal recommendation is not to use it unless you're scripting automation. That is because any removal command in Docker is permanent and there is no way to undo it. So if you would remove, let's say, a volume with valuable data or a container, that data is gone. Unless you have made a manual backup of that information somewhere else, there would be no way to restore that information. So now let's look at containers. Now containers, when you run them and stop them, they are not actually getting removed. So let me demonstrate it to you. Let's clean this up and let's run docker container list, ls actually. And you might think that you don't have any containers. Actually, by default, Docker container ls will show you only a running container. So if you'd like to see all containers, you would need to supply the --all parameter. So let's do that, --all. And as you can see, we have several containers, two in place with the status exited, and as you can see, they have not been removed. And similar to the Docker image, there is a filter parameter and a force do not prompt for confirmation parameter. Next, there is a volume prune and volume prune command, and what it does, it removes any unattached local volumes. The reason it does that is that volumes are commonly used to store valuable data. So you wouldn't want to accidentally remove any volume with valuable information. And of course, there is a volume rm command that if you'd like to specifically remove something, you can always do that, but you need to bear in mind you cannot undo that action once it is done. So Docker volume prune would simply remove any volume that is not attached to any container. And let's see. Finally, prune networks. We will cover networks in the third topic when we start talking about Docker Compose, where we will have several containers running and they will be interconnected by their own internal network. And finally, there is a command prune everything. It's a shorthand command, so instead of executing each of these commands one by one, you can simply prune everything. Now, bear in mind that volumes are not pruned by default for the reasons I mentioned, that you might have any valuable data. So to avoid accidentally losing it, volumes are not pruned by default. And if you would supply volumes, it would also prune those volumes. So let's go ahead and execute this command to show you what it looks like. And it is asking you a confirmation message: all stop containers, all not unused networks, all unused volumes or dangling images, or build cache. And we say, and by the way, it defaults to no by default. So in case you accidentally hit enter, you won't remove your valuable information. Now let's say yes, hit enter, and it has removed everything. And that pretty much covers our in-house keeping. It's very simple, it's very straightforward. And now we can move on to the Dockerfile and creating your first custom image. So the final part of topic 2 is creating our own custom image using our own Dockerfile. So this will be subsplit into 3 sections: Docker build, which is command line used to build Dockerfile, Docker image from Dockerfile. Then I will talk about Dockerfile reference itself. And finally, I will quickly go over best practices for writing Docker files. So let's get started with Docker build. So what is Docker build? Docker build allows you to create Docker images from Dockerfile. Dockerfile, as I have mentioned in topic 1, is a simple text-based file without any extension, and I will cover it momentarily, but for the moment I will cover Docker build. So as you can see, it's plain text, nothing special, and the command itself is docker space build provided by options, and then you have path, URL or std in. For our instance, this is the command we are going to use. -t allows you to tag an image, which allows you to create meaningful names for your images, so you can create containers from your custom images. Dot at the end means that we are looking for Dockerfile in our current directory. If you don't specify an alternative name, Docker is going to be looking for a file named Dockerfile. If you want to use an alternative name, such as, for instance, shown here, Dockerfile.debug, you would need to specify it with -f parameter. So let's go ahead and build the image. And the image was already created using cache. Now I'm going to prune our system so to show you building process from scratch. Let's go ahead and build it. As you can see, now it will download all the images and run every command. This is, by the way, a good demonstration of why layers are so important. As you can see, if we have already built the image, Docker will reuse cache or cached layer, so it doesn't have to repeat the same steps. It is something like dry, don't repeat yourself. And now we have our custom image, so let's docker image ls, and there we go. We have our image here. So now let's go ahead and run it. To do that, we would just run our Docker container as any other. Docker run and specify the name of our image, which is my world. And as you can see, it has output as hello world. This is a very straightforward process, and I have covered most common parameters used here. Once you're looking at more complicated setups, you can become more familiar with them, but for the time being, if you're just getting started, it's best to keep it simple, and once you're feeling confident, you can move on to the more complicated stuff. So now let's cover Dockerfile. Dockerfile is a simple text-based file where each line represents a new command. Let me demonstrate our current Dockerfile. As you can see, this is what it looks like, but let me open it in a more user-friendly way. So every Docker file has from parameter, which specifies which base image are we using to create it. Generally speaking, you would use some kind of an existing image to create your custom image. There are more advanced cases where you would create an image from scratch, but it requires a better understanding of Docker system in general, so it is something that is aimed at more advanced users. Then we have the next line, work dir, which sets our working directory. And then we have our command, which actually creates a file. I will demonstrate it in a moment as this file has been created, but simply put, we are creating directory, changing to our newly created directory, and creating an empty file. Finally, we have a cmd, which outputs hello world. So you might ask, what is the difference between run and cmd? Run is executed during the building stage, but cmd is executed during the runtime. Let's say that you have created an image with a linter, right? So if you would specify that you would want to link current directory, let's say JavaScript files or PHP files or anything else, if you would specify it as a part of run, what would happen is that during build, the Docker would link your current working directory, and then on each subsequent runs, it wouldn't link your current working directory, but would rather refer to the layer. So anything you want to be executed at runtime has to be specified from CMD. Now, bear in mind that if you look on the CMD, it would say that there can be only one CMD instruction in Dockerfile. If you list more than one CMD, then only last CMD will take an effect. So you might ask, well, what can I do for to run multiple commands? Very simple. You use a double ampersand. Let me demonstrate and echo 1, 2, 3. Let's save. All right. Now we need to build the image. Remember that when you have edited Dockerfile, you always need to rebuild your image. It doesn't happen automatically. It's something that you need to specify yourself. See Docker build, hit it. So as you can see, the layers which have not been changed are using cache, right? But the ones which have been changed have been compiled. This is very efficient if you have a very large image. So now let's go ahead and execute our custom container, and there you go. You have executed 2 commands. Now let me also demonstrate that the files specified by run have actually been created. Let me show you. We will write docker run. We would want to say that this is going to be an interactive session. Name of our image and bash. You can read this command as the following. I want to run my world image in an interactive session, and once the container ready, it should start bash. So let's see that we are in our system. As you can see, we are now in our container running the custom image, and let's see my dir, right? So let's type cd my dir, right? The directory was created, lsl, and as you can see, the file was also created as well. Now, if you want to copy files or add them, there is a special parameter, add or copy, which is what you want to use if you are going to be copying any data. So the purpose of run is to execute commands, but if you want to, say, copy directories or files, you would either use add or copy. So at this point you might ask, what is the difference between add or copy? Jumping a little bit ahead, there is an article called, scroll to the top, Best Practices for Writing Docker Files, which is available on Docker Docs, and they have a specific subsection called add or copy. And they generally recommend that copy is preferred, and then they go into a more, let's say, technical explanation where results might differ. Now let's look at the remainder of our Dockerfile reference and provide you with a quick summary. You would want to start with a from parameter to specify from which image or which image is going to be as a base image for your custom image. Then you would use run for any compile time commands and cmd for any runtime commands. As I have mentioned, you can have only one cmd, and if you want to run multiple commands, you would have to change them using this double ampersand. Now, if you want to copy any files or folders, there is a dedicated copy command. There is a workdir parameter which allows you to specify workdir. This can be used as an alternative to cd. And finally, let's have a look at the volumes. Volume allows you to specify the path to the volume from within container's point of view. If you remember, when we were mounting a volume, either bind mount or a volume, we would have 2 parts. The source part specifying the location, specifying either the source on the host if it's a bind mount, or the name of the volume if it's a volume, and then destination would specify the mounting path within a container. So if your Dockerfile contains this parameter, you don't have to specify the destination, as this parameter would take the default value. So now let's talk about the last part of topic 2, which is best practices for writing Docker files. This is an official guide, or let's say recommendations from the Docker docs itself. And as you can see, this article is quite big, but I definitely recommend going over it and becoming more familiar so that you do not follow any bad practices or anti-patterns when you're creating custom images. For example, one common anti-pattern when creating Docker images for the first time is lumping together everything under a single run statement. How this is something like this. And let's say you have a very big command that takes maybe several minutes or maybe even, let's say, 10 to 15 minutes to be executed. Now, let's say that if you would make any change, even just, let's say, the name of the file, because from Docker's engine point of view, this is a single layer, it will have to rerun the entire command, so it would be very resource inefficient. So in that case, what's recommended is to split the command into several ones. So let's have a look. Let's build our file, right? And then let's run it second time, so it's using only cache. Now let's create another file here. Say touch another file, and then let's hit build. And as you can see, the only layer that was rebuilt is this one. The previous one, which is mkdir, was not touched. Everything else was created using cache. So this pretty much should cover all the basics for beginners when they approach Docker from a command line perspective, and when it comes to creating custom Docker images using your own Docker files. So now I will be moving on to the part 3, where I will talk about Docker Compose, which uses pretty much the same concepts as what we have covered now, but Docker Compose allows you to create a uniform config where, let's say, you have your application container and you have your service dependencies. And Docker Compose file allows you to create a single config, so you have a repeatability. So let's say you create a config and then you would upload it to your, let's say, CI server, and then your CI server would create an identical setup, to the one you have on your local machine. Or let's say you are a development team and you would like to use the same development environment. Well, Docker Compose allows you to create a config for all these subjects we have covered, such as specifying exposed ports, name of the volumes, name of the containers, etc. So we have reached the final part of this video course where I get to talk about Docker Compose. Docker Compose is split into two parts: the CLI component, the Docker Compose commands which you would run in your command line, and the Docker Compose reference file, which is typically referred to as docker-compose.yml, which is YAML format. So what is Docker Compose? I have shown you in the previous part that you can create containers using command line, how to access them, etc. However, when you're running applications, more often than not you have dependencies, such as databases. These databases, as I have mentioned in topic 1, should be created in their own containers, which are known as service containers or dependency containers. So let's take a LAMP stack as an example. You would have your Apache container, you would have your MySQL container, you would have your PHP container. So one of those containers is going to be your primary one, which will contain your application, and others will be your service containers known as dependencies. So what Docker Compose allows you to do is to create a config where you would define all of your containers from a single point of view. So instead of creating each container separately, you would create a single config file, and then the Docker engine would take care of the rest. So let's get started. So what is Docker Compose and how does it differ from Docker CLI? Well, Docker Compose is a specific subset of features of the Docker engine aimed at Docker Compose config. So what is Docker Compose config? As I have shown in the previous part of the video, you can configure a container using Docker CLI. But let's say you have an application that consists of 2 or more containers, so you need to define, let's say, dependencies, ports, etc. It's going to become very cumbersome or inconvenient to start each container manually, to configure each container manually, etc. So what Docker Compose does, it creates a single config from which you can create multiple containers defined in a specific way. So this is a very popular way to actually, let's say, deploy applications, create a repeatable development environment, etc. One specific difference is that Docker Compose can work only if you have Docker Compose file in place. So allow me to demonstrate that. Let's type Docker Compose, let's say ps. And it will say that Docker Compose ps is not in place. So in order for Docker Compose commands to work, we need to have, show you, Docker Compose config in place. So once we have established this, let me quickly go over popular commands, and then we will start looking at the Docker Compose reference so you know how to edit or even create your own Docker Compose configurations. So the first command I'm going to look at is Docker Compose app. Docker Compose app is essentially a very simple way to get started. So let's say we have downloaded this, let me clear this. Let's say we have downloaded Docker Compose file from the internet, or we have cloned our repository. So we would like to get started using the same environment as other people do. So we would simply type Docker Compose app, and it would start creating all the services and configure them according to our specification in the config file. Once we have done, similar to Docker CLI, we would hit Ctrl+C, and the system would stop the associated containers. And that's pretty much all to the Docker Compose. Now, as a popular switch, as you might be already familiar with it, which is -d or --detach, which allows you to detach from the container so they're running in the daemon mode. You can also get yourself acquainted with other parameters, as usage of them will depend on your workflow. In other words, there is not really a right or wrong way to go about it, but it's simply different organizations or teams use different styles, so they might use or might not use certain parameters based on their workflows. So the next command which I'm going to look at is Docker Compose down. Essentially what it does, it's a shorthand for two things. It's going to stop the containers defined in the Docker Compose config, and it will also remove them. It will also remove networks, volumes, and images. So by default, containers are removed, networks are removed. And if you would specify volumes, named volumes would be additionally removed. Now, from personal experience, I would say that you wouldn't want to remove images, because images, having cached images would substantially accelerate your workflow. So every time you recreate your containers, you don't need to wait for the images to be downloaded. Instead, the Docker will use cache. The next command which I'm going to show you is Docker Compose ps, which is similar to Docker ps, but instead of showing all containers running within Docker engine, Docker Compose ps would only show containers relevant to the current Docker Compose config. Now I will quickly cover the remainder of the commands and we'll move on to the compose file reference. So Docker Compose build, you would use this command in case you have a custom Dockerfile which you would like to build as a part of your service containers. You have your Docker Compose config command, which simply validates your compose file. Now there is another command, Docker Compose create, which you should no longer be using as it is deprecated. And the last two commands which I will mention is start, which starts the existing containers for a service, and stop similarly stops the containers. Now, the difference between, let's say, start and up is that Docker Compose up would create containers if they're not existing, whereas Docker Compose start would simply start existing containers. And the same applies for stop. Stop would simply stop the containers, but Docker Compose down would also remove them. And additional commands which you can make yourself familiar with, as it's always a good practice to be familiar with as many Docker related commands as possible, as this is quite large ecosystem and it would probably take for you some time to become familiar with it if you are starting it for the first time. Now, in terms of housekeeping, there is no special commands for housekeeping. So if you wanted to remove containers or images created by the Docker engine, you would go by already familiar to you commands such as Docker image prune or Docker container prune or even Docker system prune. So there are no specialist commands for deleting existing images. You would use already previously known to you Docker CLI commands. Now that I have quickly covered Docker Compose CLI, I will show you how to actually use it in practice. So let's clear our terminal, and to start on a clean slate, let's run Docker system prune, and we want to remove everything. All right, so we are in our folder where we have Docker Compose file. How do we get started? We would simply type Docker Compose up, but this time let's specify D, standing for detach, so we can still access our terminal after our containers are up. So as you can see, it is going through the same process, downloading images layer by layer, but instead of starting just one container, it's going to start two. And as you can see, the process is fully automated and it is up. So let's navigate to the public IP of our Docker engine. And as you can see, it is showing us a WordPress website. I have configured it in advance to save up time on the video, since the point of this video is to make you familiar with the Docker Compose and not WordPress. So as you can see, the process is relatively straightforward and simple. Now, before moving on to the next part, let me demonstrate how to use some other commands, and then I will cover Docker Compose config itself. So we have our containers running, so now let's stop them. To do that, simply do Docker Compose stop, and it would stop our containers. So to clarify, it would stop them, but it would not remove them. So the next time we want to access the system, we would simply type Docker Compose start. And once we are done with the system, we can simply type Docker Compose down, and it will remove the associated containers. From personal experience, my favorite way is to actually use up and down, since let's say you're developing and you're working on a new feature and you have been previously working on some other feature. So it's a good idea to start with a clean environment so that you don't get any, let's say, artifacts or any side effects. And Composer is great at that. You just simply type Composer down, existing containers are removed, then you type Composer up, and exactly the same environment is created, but because the process is fully automated, you do not need to do anything else. Now let's have a look at the Docker Compose config in more detail. So the first line in the Docker Compose is usually the version number. Now this version is very important because this version determines what features are either available or missing from the Docker engine. As you can see in a Dockerfile, in a Compose file reference, you have three major versions. So whenever you're dealing with, let's say, legacy code that would say version 2 something, you would need to look in the version 2 or even version 1. Because based on the Docker engine's version, availability of certain features may or not may be there. So now let's have a look at the rest of the file. You have two top level keys here, which is services and volumes. I'll start with the volumes. Now, volumes defined as a top level is a place where, let's say, you would specify a driver for your volume in case you're not using a local one, but let's say a remote system. This is where additional options or configurations would go. Now, under services, this is where you would define your containers. Each container has its own unique key, such as we have here DB and WordPress. And under each key, you have container-specific configuration. So each container needs to have an image key, because an image key defines what is the base for that container. Like you have seen in the Dockerfile, there is a from attribute which specifies the base image. Similar thing applies to Docker Compose. However, unlike a regular Docker CLI, you can specify a path to Dockerfile here. So as a part of starting your containers, a new image would be built. So let's have a look at that value. If you look in the compose file version, right, reference, you would find key named build. So let's click on it, build. And in case you are using Dockerfile and not publicly available image, by the way, images specified here are looked up in Docker Hub. So any image which you would specify here would be looked up on Docker Hub, and it needs to be public one. In case it is a private one, you would have to configure a private repository so that Docker Compose would know where to look for your Docker images. And simply put, the process is very similar to Docker process of building a new image. You would simply specify a path to the folder, or you might specify even a Dockerfile name in case you have a different file name for your Dockerfile. So it's very straightforward, nothing new. As you have seen, when I was starting a Docker, it was specifying the names of container in this manner. However, you can override it by means of container name. It's a special property that allows you to define custom name for your container. So let's go ahead and try it. First of all, let's make sure we don't have any containers in place by running Docker Compose down. So everything was removed. Now let's specify here, let's say my DB, and let's specify here under after image my WordPress. And now let's type Docker Compose up and hit enter. So as you can immediately see here, the container names have been adjusted according to our config. Now let me start this in detached mode so I can show you from a different point of view. Let's start Docker Compose detached. And there you go. Our containers have been given custom names, and if you would type Docker container ls, we can see these containers in place with their respective names. So now let's move on to the next part. So now let's have a look at volumes. Before starting here, let's have a look in the reference manual to see how we can configure them. Let's find here volumes. Here we go. Scroll it up. And we have actually two subsections here. There is a short syntax, which is the one we are using. It uses a single line. And there is a long syntax where you can specify parameters. As you can see, the parameters here are exactly the same as for Docker CLI. So you have your type, source, target, read-only, etc. So in a shorthand syntax, what do? We specify source as an optional, and then we specify target with an optional mode. So how this works in here? We have a volume named DB data, and because it doesn't have any configuration in place, Docker engine is using a local volume. So the first part is we're specifying the name of the volume, which is says here, source, which is followed by the target, which is path to where the volume is going to be mounted within a container. So now let's go ahead and access our container to see the contents of the volume. So let's see, are we running the composer see we are running our containers, very good. Now let's access them. To do that, we would need to type composer, docker compose exec, and then we need to specify the name of the service as defined in the config file. So we wouldn't use the container name, but we would use the service name in the YAML file. It's db. And let's type here db, say bash. There we go. And now let's navigate to this path. Copy. And this is what we have in our volume. So as you can see, everything is very similar to Docker container or Docker CLI. And the last part which I will show you is to how inspect the volume. So let's see, let's type docker volume ls, and we have our volume here, and type docker volume inspect and specify the name of the volume. Hit enter, and as you can see, we can inspect our volume like so. And by the way, the name can be changed also using docker compose config. And now let's move on to the next part of this video. But before doing that, let's stop our containers. All right, excellent. So now let's go to the next step. So now let's have a look at ports. But before doing that, let's head over to our reference file. There we go. And as you can see, just like volumes, there is a short syntax and there is a long syntax. Our config is using short syntax, and it's the same. It's very, very similar to how you would do it when you're running Docker CLI. But if you'd like to specify more parameters, you can use a long syntax such as target, published, protocol, etc. And as with a short syntax, the first port is the host port, the one that you're going to expose, and the container port is on the right hand side. Just like so. So let's say we would like to change our port to 8080 and see what will happen next. So let's open up our config. It's open, change it to 8080, hit save, and then here type docker compose up and let's detach it. All right, so now let's head over to our browser and specify port 8080, and it has worked. All right, let's move on to the next part. So now let's have a look at the environment key and what it does. Environment key is essentially defining environment variables for your container. Now it is a pretty popular way to configure your application, such in this case we are doing it for WordPress. So let's go ahead to the reference file and find the environment section. Here we go. And as you can see, you can define your environment here. There is two syntax formats which you can use. Ours is using the first one. We are using a white space. And this is pretty much it. You would simply define the name of the environment, and then you would set its value. So now let's go ahead, access the container, so we can see how it looks like from container's point of view. So now let's open our terminal and let's access the container which is currently running. Composer exec. By the way, a very important difference between Docker compose exec and Docker exec is that whenever you're running Docker exec, you need to specify -it to manually allocate TTY and specify that it's going to be an interactive session. When you're using Docker compose exec, by default, TTY is allocated, so here you're going to use the opposite. You would need to specify a parameter if you would like to disable it instead. So now, let's go ahead, Docker compose. I will specify here WordPress. A reminder is that you will specify here the key and not the container name. And you will specify bash because we would like to enter interactive shell. Docker. I made a typo, it's not composer, it's compose. And now let's echo our environment variable, let's say host. And as you can see, it has this value, which is exactly as we have specified it in our config. Now the next property or key which I'm going to cover is the restart value, which we have not previously encountered before. So let's find it in the reference file. And this is what it does. It has 4 possible values: no, always, on failure, unless stopped. So in other words, we can specify a policy what should happen in case the container, let's say, stops or fails, etc. So in our current example, we have set it to always, which would mean that if the container is going to be stopped for whatever reason, it's going to be restarted by the Docker engine. So let's go ahead and try it. We are inside our container and let's specify shutdown H now. Exit. So the next configuration key which we are going to cover and which we have not previously encountered is a restart. So let's have a look at the reference. It has 4 possible values and ours is currently set to always. And you can read more about the restart policy and how it works. So one important thing to bear in mind that when you specify always restart, if the container is stopped manually, it is restarted only when Docker daemon restarts or the container itself is manually restarted. So let me demonstrate to you the point. Let's see, are we running our containers? Docker compose ps. We are. So now if I would execute docker stop my, let's say, WP, it would not restart automatically because we have indicated to the daemon, Docker daemon, that we are stopping it manually. So this feature is useful if you're running your application in production. Let's say it crashes and you need to automatically restart it. So let's say your end users are not affected. I'd say it's not so common, let's say, in the development or in CI testing, because if something crashes, normally as a developer, you would manually investigate it and try to resolve the bug or at least find a workaround. So now we are going to move to our last feature, which is depends on. Depends on is Docker Compose specific feature because by the nature of Docker Compose, we can configure several containers simultaneously. So let's have a look at what it does. See, gonna open depends on. And what it allows us to configure is to expressly set dependencies between the containers. But there are a few gotchas which I'm going to mention now. And they're actually listed here on the website. So depends on does not wait for the container to be ready. It simply indicates the order in which containers will be started. So to paraphrase it, when we specify depends on, it means that our WordPress container depends on DB container. So what this means is that Docker engine will first start DB container and only then will start WordPress container. However, Docker engine would not indicate when MySQL, in this particular case we are using MySQL, it's not going to indicate if MySQL is ready or not. So what is commonly used is so-called polling script, which would periodically, let's say, provide an update showing whether the container is ready or not. And we have reached the end of this video course. Thank you very much for watching. Please check out the videos on the right for more information to help you develop your IT career.